Okay, good morning, everyone. The quiz, the test on module 1, other day which I had circulated. You have any problems? Weren't you, if at all
So
you know,
I have one.
okay, which problem is there?
So there was this question in which we were supposed to find out the power through the 16 ohm resistor. I couldn't get that one.
Okay, power fed to a 16 ohm resistor, right?
Yes, sir. You have to calculate the power through that, and there are multiple series and parallel resistance.
Okay, okay, fine. Wait, let me just take out those questions. Okay, so the question was something like this. There was a battery in series with 10 ohm. The second battery was in series with 20, and the third battery was in series with 30, right? So this is 10, 20, 30, 120, 90,
So not this
and
one.
then,
So there is a question you have to find out the power in the 16 ohm resistance.
okay.
So it goes like there's a 100-volt battery
Huh.
which is in series with an 8 ohm resistor.
Okay, okay, 1 minute. What you do, you just send that screenshot in WhatsApp. I'll solve it.
So I don't have a screenshot. I've drawn it in my book. I'll send you that.
Yeah, that is also fine. Okay. The other one was series parallel reduction.
So that was the 5,000 and 1,000, 10,000 ohm. Not that one, sir.
Okay. Send me in the WhatsApp. Let me see. Yeah, I got it. The 100-volt battery problem, right?
Yes, sir.
So all numbers are basically resistances. Okay. So this was a problem, and you were supposed to find P16, right? P16 you were supposed to find. There are two ways of solving this problem, okay? In method 1, what you can do is, in first step, probably you try to find out R equivalent, that is equivalent resistance of the whole network, okay? So that you reduce the network to this form. You'll have a single battery and a single resistance, okay? And this will be your current. Okay, so you'll get some current here. Okay, having known that particular current, what you can do is, okay, so you will come to know about this particular current, right? Using this series parallel reduction. Now what you can do is, you can think of applying current division rule. Apply current division rule. Now, to apply current division rule, what you have to do is, first you have to reduce this particular network. Okay, it's something like 4 ohm, 16 ohm, and 4 ohm are in series. Okay. So the network,
So I have a doubt, sir.
yeah, tell me.
So instead of using current division rule, we can use the voltage
Mesh
division
analysis.
rule, sir.
Yeah, mesh, yeah, voltage division rule also you can use.
That makes it
Now,
more simpler.
yeah, you are saying you will know this current, right? Some X amperes. No, that's the reason I said method one. Okay, there are multiple methods since the question was raised. So I was just discussing about the different possible method. There are three methods actually. The first one was the current division rule, as I was discussing. The second one is the mesh analysis. Okay, because you take I1, I2, and I3. So whatever I3 you get, right? This is I3, no? So that I3 basically,
Sir.
yeah, I3 square into 16 ohm is nothing but your P16. Okay, that is also possible. Just talking about the possibility. So in current division rule, if at all you want to take, this you will reduce, right?
12.
This is 6, and you will have one more equivalent. Let's say R equivalent dash. Okay, and then again you can reduce the 3 into 2. Sorry, 1. So basically, you will have something of this kind. Okay, so this is your 24 ohm resistor, and this is your R equivalent double dash. So this is your current I. This is I1, and this is I2. Something of that kind. So like a chain reaction, chain rule you have to keep on applying. Okay, so that's current division rule you can try out. Okay. The second one is, as your friend mentioned, voltage division rule. Okay, probably he wants to see, you know, the current, right? Some X amperes of current flows, and this current will produce some voltage drop here, and that same current will produce the same voltage drop across the bottom resistor as well. Correct. So the remaining voltage, that is 100 minus Vx and minus Vx, will appear as Vy across 24 ohm resistor. Okay. Then having known voltage, you can find out this current. Something of that kind you were suggesting?
Yes, sir. Like
Yeah.
that, we can divide the next side also, and then we get the voltage around the like across the 16 ohm resistor.
Right, right.
Then we use V square by R and get the power.
Yes. Okay. So voltage division rule as discussed, and third one is mesh analysis, which I have already discussed in the previous classes. Okay, now whichever method you use, basically you will have to get a common answer, right? So P16 you are supposed to get it something like 12.745 in and around. Are you getting it? This was the answer. This was the answer. Okay, so try out. Now, next week I'll take tutorials. Okay, so I'll give you a week of time. That is Tuesday, right? You have, okay, Wednesday you have tutorials. So shall we meet up for today's tutorial, and we can discuss about these problems, whatever you say, this week or next week. The option one is today we will discuss. The option two will be, you will go back and you will try to solve all those 10 problems, and you can discuss in the next tutorial week. Tutorial week as in remedial class week. What do you suggest?
So can you send questions to the group?
The questions are same, right? What was there in the quiz? Oh, you're not able to see it, right? Once you submit. All right, I will send the questions. Okay, fine. So today, let me start with a new module. Okay, that is module 1B, which is fundamentals of single phase AC circuits. Okay, fundamentals of single phase AC circuits. Okay, in the introduction class, I had classified the supply system, right? Since many of you had not attended the introduction class, that is class number 1, let me quickly do the recap. Okay, now supply system are broadly classified into 2 types: AC supply and DC supply. DC supply. The circuits which work on DC supply are called as DC circuits, about which we have already studied in module 1. Okay. On the other hand, the circuits which work on AC supply are called as AC circuits. AC circuits. Okay. All right. Now, in AC circuits, there are 2 types. Okay, single phase AC circuits, which work on single phase AC supply. And the second classification is 3-phase AC circuits. Okay, in short, let me write 3-phase AC circuits. 3-phase AC circuits, they work on 3-phase AC supply. Okay, so basically in this particular module, okay, we are going to talk about this part of the portion. Okay, this is module 1B, wherein which only fundamentals of single phase AC is dealt. Okay, and an extension to this single phase AC circuit, you have module 2A, in which you can say a little more in-depth analysis of electrical circuits will be carried out. All right, fine. Now, what is this single phase AC? Okay, I'm explaining this because you would be needing this in your lab as well. Now, in case of single phase AC circuits, okay, first let me give you the example. Your household supply. Your single phase AC is nothing but household supply. Okay. Basically, you will have 2 voltage level. One is at 0 volt and one more is at 230 volt RMS value. Okay, that's the reason, you know, normally we say that single phase AC or the supply which is available at our homes is 230 volt AC. Okay, so that's the thing. Now, these 2, you know, terminals, or I mean, these 2 voltage levels usually have some color representation also. Normally, you know, the one terminal is given with phase, okay, naming, and the other terminal is given with the neutral terminal. Okay, but you can interchange because as such AC is bidirectional. Okay, if you measure from say phase to neutral, or if you measure the voltage from neutral to phase, will not change. It remains 230 volt because the signal is bidirectional. Okay, even then, you know, one terminal we call it as phase and the other terminal we call it as neutral. And phase terminals, okay, can be identified with a red wire. Red wire. Okay. On the other hand, neutral terminal is identified with a black wire. Black wire. Okay, this is called as wiring code. Okay, actually we are supposed to follow this particular, you know, wiring code, but sometimes, you know, electricians, they'll change the color. But even then, okay, in place of red wire, if the electrician chooses yellow wire, okay, yellow wire, no problem, because the copper conductor remains the same, right? Only the outer jacket will vary. But in order to identify the phase and neutral terminals, this particular neutral wire is always, you know, kept in black color only. Okay. So this is how you can identify the terminals of a system, which will help you in while carrying out the repairing work. Okay. So only two wires are found in AC system. Okay. Sometimes, along with these two wires, you will also have a third wire, which is called as the earth wire. Okay. Now, this earth wire will not be found in each and every appliance. Okay, so this earth wire normally found in appliances where the power requirement is very large. For example, iron box, water heaters, mixers, washing machines, etc. So all these appliances, they work on very high power levels. Okay, so the operating current, okay, I operating is high. Okay, is high, and to protect the human lives against, okay, an unintentional fault, this earth wire is used. So this earth wire basically provides a very low resistance path. The resistance of earth circuit way lesser than the human body resistance. Hence, the leakage current always, tries to flow through the low resistance path, and that's how it protects human lives. Okay. So this is your single phase AC system. Okay. On the other hand, your three phase AC system will have further two types of systems: three wire system and four wire system. Okay. In three wire system, you will not have one phase, you will have three phases in order to identify. Okay, let me write here three phases you will have. On the other hand, in four wire system, you will have three phases. Along with the three phases, you will also have one neutral. Okay, one neutral. Now, the three phases are red phase, Y phase, P phase. Okay, so if you find a red color wire, that means to say that's the red phase. Yellow wire stands for yellow phase, and B stands for blue phase. Okay, why not all three reds? Because the voltage magnitude may be the same, but the angle between the voltages are not same in case of AC system. Okay, in the sense something is lagging, something is leading. Okay, never worry about it.
Sir, and this all three wires are live wires, sir?
Yeah, all three wires are live wires. And in the Indian system, all three wires will have same potential. Okay, that is voltage between R to I is VL, Y to B is VL, and R to B is also VL. And for Indian system, VL is either 440 volt or 415 volts. Okay. On the other hand, the angle between let's say VR, VY, and VB is 120 degrees. Okay, that's the reason. This concept later I will explain you. Okay, just over here, my aim is to just discuss about the supply system classification. Okay, now why three phases? That's because with the help of three phases, you will be able to do more work. So three phase AC systems can do more work compared to single phase system. Okay, and that's the reason this three phase system is used in your electric cars, wherein the torque requirement is very, very high. So when the torque requirement or the power requirement is higher, go for three phase AC systems. On the other hand, if torque and power requirement is lower, go to single phase AC system. That's the reason in household situation we go for single phase AC systems, and for the industrial applications, okay, that includes electric mobility as well, we go for three phase AC supply. Okay, so that's how we broadly classify the three-phase AC supply from a single-phase AC supply. It's totally based on the power requirement. All right. Okay. Next.
So,
Yeah.
is three-phase used in industry is because like for motors they don't have to use starters when using the three-phase.
Yeah. I mean, starters you are saying. See, for single-phase motors, you need starters. For three-phase motors, you don't need starters. Even then, we use starters in three-phase motors just to protect the motor against high currents. Okay, but the reason behind the usage of three-phase AC in industry is that their power requirement is very, very huge. Now, for the large power requirement, if you think of using single-phase electricity, what happens is that the equipment size increases. Okay, so what will happen? The industry would be needing larger space to accommodate those motors. Okay, so that's the reason they switch to AC, three-phase AC. So with three-phase AC, they can use a smaller motors for the same power output, and they can also achieve higher efficiency. They can also achieve higher efficiency. Okay, let me discuss only 2 points. Efficiency, if at all if I talk about the single phase motor efficiency is about 60% maximum. Okay, max efficiency will be around 60%. On the other hand, if we use three phase AC, please mute your mic. I don't have to remind you. It's your duty. Okay. On the other hand, if you use a three-phase induction motor or any AC motor, you'll get the efficiency at the maximum 85%. So there is a clear-cut increase in efficiency. Okay, so that's the reason. And in industry, it's something like they work almost 24/7, right? In shifts they work. So for them, it matters a lot. They can save huge amount of revenue by reducing the electricity bill. Okay. All right. So that's the broad understanding of why three-phase is preferred in industry and why single-phase is preferred in domestic applications.
Excuse me, sir.
Yeah.
So what is the color of the earth wire?
Black. Sorry, earth
Sir,
wire.
earth wire.
Green. Earth wire is green. Green color. Earth is green. Okay, and you can easily identify the earth pin from your wall socket also. I think this I have told you. In high power equipment such as iron box, water heaters, washing machines, along with line and neutral terminal, okay, you will also have a terminal which is having the larger diameter, okay, which is your earth pin. Okay. So this gets into the wall socket. So wall socket will have 3 holes: the earth hole, line, and neutral hole. And this earth terminal of the wall socket is basically connected to the earth pit. Okay, so this is your earthing equivalent. Okay, so earthing is normally indicated by this symbol. Okay, this is called as earth symbol. Okay, so your wall socket, right? In your wall socket also you have line, neutral, and earth, right? So internally, this particular earth socket is connected to the earth pit. So if there are any leakage, okay, if there is any current leakage, the current will flow through the earth. Okay, that's because this particular resistance is kept somewhere between 5 to 10 ohms. 5 to 10 ohms, which is very, very small in comparison to human body resistance. Okay, any guess about human body resistance? Any wild guess?
So it's around 10 kilo ohms, sir.
10 kilo ohm, right? So human body resistance, not happy birthday, human body resistance, 10 kilo ohm for a dry body, completely dry body. Okay, I'm talking about normal human beings. You know what I mean, right? You must have seen in replace, believe it or not, they can handle large amounts of currents also. That's because their skin resistance is different. Okay, if at all, if you were to consider normal human beings, okay, they are called as superhuman beings, right? Okay, if at all you consider normal human being, on an average, the complete body, the resistance, dry resistance is about 10 kilo ohm. On the other hand, if the body is completely wet, the resistance is as low as 100 ohms. This is for wet body. Wet body. Let's say you are completely drenched in rain, and if you happen to contact live electricity, and if at all that particular appliance has earthing, the current still flows through the earth rather than flowing through your body. That's because your body resistance is about 100 ohms, but earth resistance is always maintained at a very, very low resistance, that is about 5 to 10 ohms. So current always prefers low resistance path. So that's the reason, it is very important to have a proper earthing at our homes. Okay, and every individual house or apartments will be connected to the earth pin or earth pit. Okay, we have an instrument to measure earth resistance also. And that is included in your basic electrical laboratory as well. Okay, so the moment when the physical classes starts, you will be able to understand how to measure the earth resistance, etc., etc. Okay, any doubts till now?
So what about two-phase resistor, two-phase AC circuits?
Okay, two-phase AC circuits, possible. Okay, you can generate two-phase AC circuits, but you don't have any appliance in reality. Okay, but you can produce two-phase AC. Now, to produce two-phase AC, what we do is that, now if you consider your fan, okay, fan works on single-phase AC, correct? So single-phase AC, as in this particular fan will have only one type of winding, phase and neutral, which is energized at 230 volt. Okay, this I'll call it as winding or coil. On the other hand, let's say you consider three-phase AC. As I said, in three-phase AC, how many live conductors are there? 3 live conductors, red, yellow, and blue. So you will have a separate coil for Y, and you will have a separate coil for B as well. 3 conductors. On the other hand, if at all you want to produce two-phase AC, you're going to use 2 conductors. Okay. So let's say the voltage is V1 across conductor 1 and voltage is V2 across conductor 2. Now, two-phase AC you can generate provided angle between V1 and V2, you keep it around 90 degrees. Okay. So if modulus of V1 is equal to modulus of V2 is equal to V, and the angle between the two is 90 degrees, you get two-phase AC. But two-phase AC, neither, the modulus of V2 is equal to V, and the angle between the two is 90 degrees, you get two-phase AC. But two-phase AC, neither, it is as powerful as three-phase AC, nor as economical as single-phase AC. That's the reason we don't use two-phase AC. Okay, because for two-phase AC, you have to convert your existing single-phase appliance into two-phase one, which is very impractical. Okay, that's the reason it is not at all used, but it is used in one very special application, that is in furnace arc in refinery to melt the raw metal. This two-phase AC is used, but not everywhere. Okay, only in a few. I think in India there are 1 or 2 refineries. They work on two-phase electricity, and that's because that arc furnace was designed for two-phase electricity, and they don't want to discard it. That's because it is working fine. You never know in time to come if that two-phase electrical system fails, then they may not repair it. They may directly change over to single-phase AC. Okay, that's the reason. For the above reasons, two-phase AC is not popular, but you can produce two-phase AC, not impossible. Okay. Any doubts or anything you want me to ask? You can ask. Okay. All right. Next, let us look at the advantages of AC over DC. Advantages of AC over DC. Okay. The first advantage of AC over DC is that AC generation is cheaper. Okay, that is, cost for producing AC is less compared to DC. Okay, the second advantage of AC over DC is that AC's amplitude or AC voltage level, to that matter even voltage bar current level can be easily altered. Okay. Now, what do you mean by altering? The meaning of altered is you can increase, either we can increase or decrease the level of voltage or current. Okay, so if you want to increase the voltage level, what you do is, example, to increase voltage level, use a step-up transformer. Have you heard about step-up transformer?
Yes, sir.
Okay.
Sir.
The meaning of step up, right? The dictionary meaning. You are upping the voltage basically. So if you want to increase the voltage, go for a step-up transformer. If you want to decrease the voltage, what will you use?
Step-down transmitter.
Step-in.
Step-down transformer. Okay, to decrease the voltage, you go for step-down transformer. Okay. And transformer design is not complex. Okay. On the other hand, if at all you increase, okay, the magnitude of DC or the magnitude of, magnitude of DC, or if you want to decrease the magnitude of DC, you cannot use a transformer. Why? Can anyone tell me? What will happen if you connect DC supply to a transformer?
So nothing can happen because like since the voltage or current does not change, like there's no magnetic flux.
Okay, right.
So the other coil does not get any power.
Say, okay. The second part, what you said is correct, which means there will be no magnetic flux, because to have the change in magnetic flux, you should have a varying magnetic field, isn't it? But in DC, you have a constant electricity, so there will be no change in magnetic flux. Now, transformer can be considered as a coil, right? Yeah.
Yes.
So let's say one of the winding of the transformer we have connected to 100 volt DC, 100 volt DC, and since coil is made up of copper, the resistance will be very, very small. Let's say some 2 ohm resistance it has. Let's say it has some 2 ohm resistance. Okay. Now, what will be the current drawn? Can anyone tell me? 2 ohm resistance. Okay. And let's say,
50.
yeah, inductance. Okay, because this is a coil, so inductance will be somewhere about, let's say, 2 Henry. Okay. But in DC system, what happens is that the reactance offered by this particular inductor is 0 ohm because frequency is 0. Okay, so F is 0. So reactance is 0. So your current is basically I is equal to V by R. Right, V by R. And how much is it? 50. Now imagine the same coil you have connected to an AC supply, and let's say the RMS value of AC supply is 100 volts, resistance is 2, and inductance is 2 Henry, okay, and the frequency of AC is 50 hertz. We are considering some frequency. When you consider the frequency, okay, what will happen? There will be some reactance, right? So and that reactance is 2 pi FL. So that is 2 pi into 50 into 2. So how much you'll get? 2 pi F is 314.
628.
Yeah, into 2. 628
28.
ohms. Okay. Now, since there is reactance, you cannot just consider it as a resistive circuit. You have to consider it as an RL circuit. So the impedance of this particular circuit is 2 square plus 628 square and the under root. Okay, under root 2 square, that is R square plus XL square. You remember, right? This formula you have used, no? Z is equal to under root.
Yes, sir.
Yeah, right. The same formula I have used to find out the impedance. So how much you'll get the impedance as? Roughly 628 ohm itself, right? Because this is very, very small. So impedance, approximately, you'll get it as 628 ohm itself. Due to which, what happens to current? Can anyone tell me? I is equal to V by Z. Voltage is 100 and impedance is 628. So current is 0.116. Yeah, approximately 0.16. So what happened? Now you tell me what will happen if you connect a DC supply to a transformer. What will happen if you connect AC supply with a transformer? With the DC supply, what was the current drawn by the inductor? It is 50 amperes. So this 50 ampere current is very, very high, and your inductor may not be able to sustain that much particular current. And due to excess heating, the coil may get damaged. That's because the coil resistance is very small, and this resistance will not be able to protect the high current. So that's the reason, we never ever connect pure DC to a transformer. If you connect, there will be a high flow of current, and due to this high flow of current, the coil may get short circuited, okay, and the coil may get damaged. On the other hand, when you connect an AC supply to a coil, the coil starts to offer some impedance, and this impedance is greater than the resistance value, due to which the coil draws a finite amount of AC current, okay, say for example around 0.16 amperes, which is safe enough to pass through the inductor. Okay, so that's the reason transformers cannot be operated on DC level. Transformers are always operated on AC level, and that's the reason it is not so easy to step up or step down the DC voltage, because you cannot use a transformer. Okay, however, you can step up or you can step down DC levels by using a circuit called inverter, which is made up of semiconductor diodes, semiconductor transistor, etc., etc. But the design of such circuit is very, very expensive as well as difficult. Okay, that's the reason in the second advantage we had mentioned AC voltage bar current level can be easily altered, and it is not so easy in case of DC. Okay, so this is one very common Viva question. What will happen if you connect a DC supply to a transformer? Okay, you can say that the coil may get damaged due to the excess current, and if the reasons are asked, probably you can explain the examiner with the help of this example. Okay, is it understood?
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay. All right. So these are the two advantages of AC over DC. Okay. All right. Now let us look at some basic definitions. I think I have about 6 minutes to spare. If you have any doubts, let's say any, if at all you have faced any practical situation with electricity, you can share it. Or any random doubts about electricity, if you have, you can ask me. This basic definition tomorrow we will take.
So if they ask the advantages of AC over DC,
Huh.
can we also mention that AC can be transmitted over long distances without much loss in power?
Actually, that was the bottleneck for AC. Good that you had mentioned that point. Now, I'll tell you, it is very interesting. In AC, let's say you want to transmit three-phase AC. Okay, why three-phase AC? Because I have told you, right? Normally, the AC is transmitted from power plant to the substation. Substation is where those big transformers are mounted in three-phase manner. Okay, AC will not be transferred in single-phase manner because I have told you three-phase supply gives very high efficiency compared to single-phase supply. Now, when you transmit AC, that too in three-phase AC manner, what will happen is you will have to use three wires. Correct? You will have red wire, you will have yellow wire, and you will have the blue wire. Okay, the color may not be there, but this is how it is. Always you will have three wires. On the other hand, if you use DC transmission, okay, DC has how many polarities? You tell me. How many terminals?
Just one, sir.
Yeah,
Positive to negative.
it's positive and negative. In DC transmission, the interesting fact is that only one conductor is used. Okay, one conductor is used. The second conductor is nothing but the earth itself, earth surface. So only one conductor you can use. Only one conductor you can use. So obviously, right, if you use only one single conductor, obviously you can reduce the transmission loss because less copper you are using. More the copper, more will be the copper loss. Lesser the copper, lesser will be the copper loss. Okay, but it looks very simple on paper that one conductor you use, so much money you can save, as well as so much loss you can reduce. But you have to have proper design, or there can be what you say leakage current in the transmission tower itself if the earthing is not proper. Okay, but in time to come, let's say in about 1 or 2 decades, the DC transmission may replace the AC transmission, but at this point of time, you cannot get into that changeover because you have already invested large amount of money in this AC transmission infrastructure. Okay, so only in phased manner you can replace this three-phase AC transmission with DC transmission. Okay, but thank you for bringing that point up. So next week, shall I start taking the remedial classes? And don't make it compulsory. Okay, remedial classes, actually, it is targeted for meant for those students who have doubts. Okay, so they can clarify their doubts and they can go. Or as a class, you can give me the doubts and I'll be able to solve in the remedial class. That also is possible, 2 ways. Okay.
Excuse me, sir.
Yeah.
So why was AC supply preferred over DC supply if power loss was less in DC?
That's what I said, no? See, this invention of or advent in semiconductor devices picked up late. By then, people have already invested huge amount of money in AC transmission system. See, the invention of transistor, or to that matter, power transistor, etc., had taken place in the late 1950s. So somewhere about 1950, the semiconductor device was invented. Before that, what do you say? The vacuum tubes, they were using it, right? But by then, people have invested in AC transmission. Now it is not that easy, or that it is not that economical to just discard the existing infrastructure. Okay, that's the reason we are still using AC transmission. So in phased manner, basically we are trying to come out of this AC transmission. That's the reason in India also, you can Google it out. Some 6-7 DC transmission lines have been set up and they are actually functioning. Okay, but there are more AC transmission lines. Okay, once those transmission lines fails, probably the DC transmission slowly starts picking up. Okay, all right then. If you are, I think it's 9:30, we'll meet tomorrow. Okay, so for tomorrow, what we will do is we will consider the definitions of AC, and we will derive some expression for RMS and average values, right? You have studied about RMS and average values. The same thing, let's derive tomorrow. Okay, fine.